So we had number of applications. We made a application plane. Then there is a hardware here. You can see the packet forwarding hardware. This hardware is supposed to be controlled with some sort of logic, because every device performs something. That operation need to be governed by some sort of logic. Earlier that logic was combined with hardware itself. Now SDN what suggested? SDN suggested that if we separate out this logic and make a separate layer in the form of control plane, then it would be easy for the third-party vendors to develop more applications with respect to this particular control layer, and we can independently control the network according to a specific choice. तो सिंपल अगर हम इस चीज़ को डिस्क्राइब करना चाहें, इट इज़ लाइक दिस कि हमारा जो ट्रेडिशनल आर्किटेक्चर होता था, उस आर्किटेक्चर को हम अपने हिसाब से रियल एनवायरनमेंट में रीप्रोग्राम नहीं कर सकते. मतलब हम ये एक नेटवर्क किसी एक स्पेसिफिक फॉर्म में काम कर रहा है. इफ इट इज वर्किंग इन अ स्पेसिफिक फॉर्म, देन ओवर द पीरियड ऑफ टाइम इफ यू वांट टू चेंज इट्स फंक्शनलिटी, यू कैन नॉट डू दैट easily. But with the help of SDN, as your control plane layer is separate out, now your infrastructure layer, that is the data plane part, it is the control plane, it is the data plane, and this application plane, it is optional. So you may merge these two part also, the application plane and the control plane and the data plane, either depict it like this or just simply application plane, control plane and data plane. So in most of the books you will see that they depict three layers. In some of the books you will see that they depict only two layers. So it doesn't matter. You just simply understand that the main thing that SDN did was just to separate out the control logic. So control plane is separated out from the traditional infrastructure, and now in the SDN architecture, this infrastructure layer just points to the dumb hardware devices. Dumb I am saying because they are unable to take some decision by their own. They cannot make their own decision. So that's why control layer will get programmed through the application layer, and here there will be some sort of user layer that is not depicted here, because again it is assumed that users are the part of application layer. So if you want to make one more layer, you can make here the user layer. User layer will control application layer. Then through application layers, users will indirectly control the control layer. And ultimately, through these two layers, users will ultimately control the infrastructure or the real network layer. So the ultimate control is in the hand of user only. But the point is, number of layers that you create in between, that is up to you. Because it's just a theoretical part. But in practical, it is just simply two layer, that is control layer and data layer. So let's move forward. Now we directly start with the Mininet part. Mininet is a network emulator. As we saw in the last slide, that SDN is a concept. Now we are trying to implement this concept with the help of a emulator, that is Mininet. So the question arises that what is the need of Mininet specific emulator only? Is there not any other emulator or simulator that is capable to simulate the SDN environment? Obviously, there are a number of choices, but we are going with Mininet because the reason is it is the suitable, that is most suitable for the SDN related development in its current form, because it is a desktop specific network emulator. You don't need any big network of real hardware. Just on the simple desktop laptop, means on a single machine, you can run your whole network. Additionally, with respect to other simulators also, like you can use NS2, NS3, and some other simulators are also there. So those simulators may also be used for SDN development, but specifically in not in NS2. In NS3 you can develop, but in NS3 also the development is relatively slow with respect to SDN. Mininet was quite prominent in terms of SDN specific development. 1 second, okay. 1 minute, please. I request all of you. There are some issues. One second. Microphone. Okay, that's all. Okay, so is it audible now? I think the voice quality would be better now. Okay. Is it okay? Yes. Okay. Okay. So we start from the last point. As we were discussing the role of Mininet in the SDN emulation. So SDN Mininet is introduced as a prominent network emulator, and we are continuing because it is developed specifically for SDN related developments. So what it does, it creates a realistic virtual environment.
It's okay now? Okay. So Mininet allows to create the realistic virtual networks. The meaning of virtual here that we don't have the real hardware devices. We have the virtual devices and we create the virtual network. And when we have the virtual network, obviously the kernel we might be the virtual, but as we know that kernel itself is not a hardware related device. It's a software component. That's why we may use a real kernel in a virtual environment. So with the help of real kernel, real switches, and the real application code, we may create a realistic virtual environment. It's a bit complicated definition for many of you, but the reason behind is that those who have not worked on a virtual environment, it may be difficult to understand that what exactly I want to communicate. But once you get into the practical environment, obviously you'll get the real meaning, what I'm talking to. So just now understand that we can create a simple network that is real in practice. Why it is real in practice? Because emulators are supposed to be different than of simulators in this meaning only that whatever you communicate or whatever you do over emulators can be practically imitated in the real environment. So just understand this thing that we are going to create a simple network that supports the SDN functionality. And if you enter this command sudo mn stands for Mininet, then you will have a network in the form of this. Here it is very simple definition actually. There will be some controllers, some switches, and the hosts. And then you will communicate in between. So let's move on. Getting started with Mininet. Uh, we exceeded the time limit, so I'll move a bit fast from here. We'll start Mininet with having 4 options. On the Mininet site also, you may check these options. These are the 4 options of VM installation. First one. Second is the naive installation through source. Third is the package installation. And fourth is the Mininet using a existing package. So in the first one, we are going to choose the first one because it is the easy and the recommended ones. What is the VM? Again, a virtual machine. Those who have not worked earlier on a virtual machine will go through this particular uh, practical series that how we are going to work on a specific virtual machine. I think Shiv has already communicated with you a VM link, and all of you have installed that in your system. So while going through the installation procedure, you might have understood the real meaning of virtual machine. So let's skip this part and continue on to creating a network. So this network, as I already shown you that sudo mn, it is just the real command. Whatever is left ahead of this all these options, these are the optional options. Sudo mn will create the network. Switch means which type of switch you are going to use, that is open virtual switch. Controller is again a option, that is which type of controller. So here it is ref, that is reference controller. Here it is topo, means a topology. So topology is supposed to be tree with a depth of 2 levels and the fan out value of 8. And finally, we are going to test this particular environment that we created with the help of sudo mn, that we are going to test with the command that is ping all. Ping all means each node will try to ping the other node. So here the same definition is written over here. Let's move ahead. And when we will try to interact with the network, so I just wrote a simple command, that is the very basic, that h2 means the host 2 is trying to ping the host 3. If it is possible, then we will understand this, yes, our network is working fine. So finally, this is the part that we are going to discuss in practical. So before moving on to the MiniEdit, we'll just simple go through these two parts, that creating a network and interacting with the network in real environment. So as Shiv already sent you the link and you have installed it, I hope so. So we directly move into the virtual environment. So it is the virtual environment. I hope all of you are able to see it. Subrima, is it visible? So this is our virtual machine, and we have installed it in VirtualBox. It is the platform that hosts the virtual environments. The second alternative is VMware. If any one of you is not aware, then these two frameworks are popularly used to host the virtual environments. So here it is an Oracle product, and we are going to have lots of options here. Depending on the specific configuration, you may choose these options and specifically work accordingly or change your environment. So firstly, system was slow. इनके साथ नहीं, इसकी विंडो बड़ी हो जाती है. चलो ठीक है, इतने में ही कर लेते हैं, बाद में देखेंगे इसको. Okay, so I have already created the network here. It is the command sudo mn, and then I tested with it. Let's skip it. We'll close it first and get onto your virtual environment. And in this environment, go to the home folder. In the home folder, you'll find a folder that is Mininet. Here it is. So under the home folder of Vagrant machine, Vagrant is the VM that is given to you. And under this, it's a home folder, you will find the Mininet. Go inside the Mininet, and again, you'll find a second Mininet. So we are 2 steps in. And now we find the examples, means those are the pre-built examples in this and other things, but we'll go back. And from here onwards, either you run here or inside this directory or at the home directory. Wherever you want to execute, you can execute, because its path is already set. When you install the specific environment, its path value is already set. And if it is not, then it will give some error, and accordingly you have to adjust it with the help of export command. So we hope that as the default behavior of any program is that to set its default root in the path directory, it will set accordingly its path. So we directly move on to the terminal. We'll open a terminal. We close all these things first. Okay. So all of you are in the home folder. From here, I'm opening a terminal. Alt Control T. You can press. It will open a terminal. Alt Control and T. T for table. So this terminal window will come up. In this terminal window, simply write mn. If you write this, then it will show Mininet must run as a root because it will try to access some of the networking drivers and software components. So obviously those are the system components. To access those components, you need to be the root user. So that's why we'll try to become the root user sudo. So now this hash prompt came. Hash prompt means from this tilde sign means from this dollar prompt we came to the hash prompt. Now we are in root privileges. So simply run it now, and it will show this particular kind of output. So here you can see that what is the initial part? It firstly created a network, then it added a controller, then it added the hosts. What are the hosts name? H1 and H2. It is the default topology. You might be wondering that where it come from. We simply gave the command mn mininet and it created the network automatically. How is it possible? Because there is a default topology in which we have a single switch and two hosts. Means two nodes are there, single forwarding device is there, and one controller is there. And there are two links from host 1 to switch 1 and from host 2 to switch 2. So this sort of behavior is here. And now this network is ready because we got the Mininet prompt. Once we got the Mininet prompt, it means that we are ready to work on this particular network that supports the SDN functionality. Okay. So from here onwards, if we want to interact with the network, then first we need to be familiar with the network. Now it is very simple topology. So we got to know that there are two hosts, one switch, one controller, because every one of these are listed here. Now, if it is big enough, hundreds of nodes, thousands of nodes, then you want to get the specific information, then there are some commands. I will tell you where to go and search for those commands and where you will get the all information. It is the Mininet website. So if you want to go there, you can go there and find the relevant information. Or I or Shiv will send you the links. There you will go and find the relevant information. So we start with the basic commands. For example, suppose we want to search the nodes in this particular network that we created with the help of simple command that is mn. So these are the nodes. Nodes means all the hosts which are functioning either in the form of controller or switches or simple terminals. So here terminals are supposed to be listed as host, that those are H1, H2, means these are our real end users. Those are trying to communicate with each other. Now, obviously, they directly cannot communicate. So they are using a switch. And then this switch is connected with a specific controller that is C0. So I hope it is just the indexing. So it is C0 means the first control. If there might be in the more than one control, then C0, C1 and likewise. So here Mininet prompt again came up. So again you can run the another command. Means it is just a simple environment like in Ubuntu. We have the dollar prompt. Here we have the Mininet prompt. Whatever you want to do, you do it. Again you get back the Mininet prompt, means the command is over. Now you are ready to enter the another command. So again, if I want to know the exact network, then command is net. Then it is the network. From H1 Ethernet 0. It is its interface. H1's interface is Ethernet 0 and it is connected with the Ethernet 1 interface of switch 1. Similarly, for host 2, host 2's Ethernet 0 interface is connected with the Ethernet 2 interface of S1. Now you can clearly see that S1 is connected with two hosts, as we already discussed. Then obviously there need to be two interfaces at S1 side. Means switch 1 has two interfaces, Ethernet 1 and Ethernet 2. And H1, H2. These have the single connection with S1. That's why Ethernet 0, Ethernet 0. Those are separate, means private for each of these hosts. Finally, these are connected in this particular manner, and it is lastly the controller. So again, we got to know that these are the nodes, these are the network and its a component part. Now what are the links? So here we'll enter links. So we have two links. Again, the information. Now the additional information what we got here is their status. Here it is written okay, okay. Means both the interfaces are working fine, and both interfaces means the both couples of interfaces on both sides are working fine to make this particular communication possible. Then two interfaces, if they talk to each other, then it becomes a single channel. In the similar fashion, H1's H1's Ethernet 0 is talking to S1's Ethernet 1, then it is making a channel. Similarly, H2's Ethernet 0 is communicating with the S1's Ethernet 2, then again it is making a channel. Means there are two links, two channels, and both are okay. Means the standard, means their current status is fine, they are ready to communicate. Now suppose we have the nodes, we have the controller, we have the links, and all is okay. Then what is the proof that these are functioning in the normal behavior? Means they are able to show the normal behavior, they are so we'll just simply ping each other. So there are numerous commands, ping all, ping a pair, or we can put the specific name of the host also to ping another specific host. Now we have only two hosts here. Then we have no other choice. Either H1 will ping H2 or H2 will ping H1. So we simply do it H1 ping H2. And as you can see that pinging is going on from H1 to H2, and respective ICMP packets, Internet Control Message Protocols, ICMP packets are coming here with the respective TTL value and its respective time value. So at this particular time period, the packet was sent. It is the TTL value, that is 64. And all these concepts are related to computer networks. So I think I don't need to go in much depth to make you understand that what is this ICMP, TTL, and time value. Whatever you doubt, more doubts you have, because we cannot discuss all the doubts in the 1 hour lecture class. So you may ask later in the theory sessions. We simply stop it through Control C, and here you can see it is Control C. I interrupted the process through a keyboard interrupt, and then we got the ping statistics. Ping statistics points to the overall statistics that we got from this ping command. Overall 46 packets were transmitted, 46 were received, means there is no packet loss. If there is no packet loss, the communication channel means those are in their perfect form. Additionally, the time taken is this much, means it is the delay, and the RTT, round trip time value. Again, the round trip time means the packet went somewhere and its acknowledgement came back. So RTT time value, the minimum value is 0.029 millisecond. Average value is 0.159 millisecond. Maximum value is 3.9, and mean deviation is 0.562 millisecond. So all these things are statistics related features, and hope all of you are familiar with all these things. Mean, median, mode, etc. These are related to statistics, and similarly min, max, average, etc. These things are quite common. So we clean this thing up and simply go there. We'll try to, sorry, clean up. that we have to go out. Sudo mn and c. Again, we don't need to put sudo here. Clean, the command that I was trying to use here, that is used in the normal environment. So for Mininet clean, you have to put the C switch. Actually, it is confusing. I am again talking about switch. When we write something with hyphen, then it is termed as switch because it is going to perform a specific duty. It may turn on or off a specific behavior of the respective application. So Mininet applications is going to be cleaned up through this particular switch. But this term switch is confusing because we already have this term switch dedicated for a specific purpose of forwarding device. So S1 is also switch and this is also switch. So better we will call this as an option. It is the option and it is the switch. So with this C option in Mininet, we are going to clean up the environment. So we just simply put it up, and in the last, we get the message that is cleanup complete. So what did it do exactly? When we put the mn-c, it means it is going to clear the existing environment. For example, suppose you are running something and suddenly it crashed up. Then it is going to be a chaos to understand that where exactly the problem went in. So you don't need to find out the problem, because if you are going to find out the problem, you need to explore the source code. And it is very hectic and cumbersome for a novice user to find the exact problem in the large source code. Even if it is small, it is not easy for the user to explore the source code and find out the exact problem. So here, just the simple option whenever your means the Mininet environment crashes out or it is not functioning something right, we will show you how exactly it is going to work. When we will work with Mininet, it will be there, because many time it crashes, many time it doesn't function well. Repeatedly will use this particular C feature. So here, whatever it is doing, it is just cleaning up the existing environment. Means after running this command, you will get a fresh version of Mininet. Whatever the earlier settings were there, those all are cleaned up. Okay. So let's move on. We are going to talk about some of the basic features of Mininet. So here, as we discussed in terms of pinging, here you can control the number of ping messages also. So if I put here h1 count as 1 and it is h2, it means h1 is going to ping h2 with a constant count of 1.
हेलो हेलो
Hello.
हाँ सर, एक्चुअल में वो mn-c वाला सर चल नहीं रहा है कोड
Okay.
कुछ
So
और।
no problem. I think there is no point to discuss here because we don't have time much here. So better you come to me later after the class. And I think you are at home or you are in the campus.
होम ओनली सर।
You are at home only. No problem. You put your number in the chat box and we will contact you back. Okay.
ओके सर।
Because at our end it is running fine. So I think there must be an issue or you are running at the wrong terminal. So that's why it is not functioning well. You are running at dollar prompt or where?
नो सर, दिस ओनली मिनीनेट ओनली। हेलो।
Okay, let me show you.
ओके सर।
See here, you just type it MNC. It is not functioning. See here, I think my window is visible to you.
यस सर।
So it is working perfectly fine. See.
Sir, we need to come out of the network, then we have to use mn-c. They are trying to write the command in the Mininet environment only. That's why it was not
No.
working.
Obviously. If you are running the Mininet environment, you cannot clean it up. It is like that you are inside window and you are trying to wipe out the window. Is it possible?
ओके ओके सर, अंडरस्टूड।
Because you must have two operating system on your systems, then you can stay in one environment and try to clean up the another environment. But if you have a single environment only and you are inside that, for example, you are inside Mininet and you are trying to clean it up, then it is not possible. Because here you can see it is trying to kill all the related processors with the Mininet, and it is trying to clean up the overall settings of Mininet. So here it will clean all the processes. So that's why it is not possible from inside Mininet. First, you need to stop the Mininet environment. You need to come out. Once you are in the Ubuntu or you are in the virtual machine setup, then you need to run this command. And again, you need to take the sudo permission. If you are at sudo prompt only, means if you are at hash prompt, then you can simply write up mn option C. Otherwise, you have to write sudo mn option C, means -C or switch C, whatever you want to call it. Okay, so it's been 3:40. So let's move on. We'll see some of the other options later on. Like first we'll run it up mn, and what was the command here? The command with respect to ping all will run. Okay, so now it created Mininet network is created here, and if we run the ping all command, then ping all, what it is doing, h1 is pinging to h2 and h2 is trying to ping h1. So two messages were forwarded and two received. Two transmitted, two received, there is no package drop. So due to no packet drop, the results are successful. That's why ping reachability test is successful. So here what we are trying to do, every host is trying to ping the every possible other host. Similarly, if we have the hundreds of hosts, the result might be long enough accordingly. Okay. So let's let me show you one more thing. PS related to processes. We are not going to discuss the PS here. H1 if config. What is this H1 if config? As we are at the Mininet terminal, so we have number of nodes here in the form of host, switches, and controller. So just mention the name of that particular node, that is H1 here, for example, and then the respective command. So we are trying to see the IP configuration of H1. Then we will write up here H1 and if config, because in Ubuntu we write if config and in Windows we write IP config. Okay, so the respective detailing are listed. In the similar fashion, you can also go for switch or for H2. So for switches, you can see here, it is the default interface. It is the related to Ethernet 1 and Ethernet 2, as we already saw in the terminal, and I explained you also why there are two Ethernet 1 and Ethernet 2, and it is the loopback, means the local address. So similar fashion, you can run the basic configuration command and you can function accordingly. Later on, slowly, when you will interact with the networks, you will get to know the basic meaning of all these things. Additionally, you can also set the number of ping messages that you try to run in your network. Okay, some more commands. No, let me stop it here only. We'll see it later. Okay, so Control D. Again, I came out of this Mininet virtual environment and we came out the virtual machine terminal, that is Vagrant. Okay, from here we are trying till now we were trying to run the Mininet as its in its default form. But now suppose if we want to create the topology in graphical form and then we try to connect the hosts with each other, or you want to see the statistics or whatever behavior we are trying to do. So Mininet is the additional functionality that Mininet provides. MiniEdit is the graphical functionality that Mininet provides to create the topologies and interact with users in its graphical form. So where is it? Again, we have to go into the directory structure. So go, it is the home of Vagrant, and then, okay, step by step I am going to show you. First, list down all the directories. Inside this, it is the Mininet directory. So change a directory, Mininet. With me only, all of you can follow if possible. I'm going to make it slow. The process is going to be really slow so that you could also follow. Again, list down the directories, ls, and again, you got another directory that is Mininet. Then cd Mininet. Then list down, and here you'll find the different examples in the form of example directory. Again, list down. Inside example, you will find one file that is MiniEdit. Here it is. So it is the MiniEdit. Now, as we are already having the sudo permission, so we don't need to write the sudo here. We just simply write the current directory means dot slash, and here we are going to write the miniedit.py, and we are going to hit enter. So once we hit enter, the MiniEdit will open up in this form. The same thing I show. No, I think I didn't show you. We stopped the presentation here only. We pinging and all these things are done. So MiniEdit, the thing I was discussing you. MiniEdit, it is the networks Mininet. The network simulator includes MiniEdit, that is a simple GUI editor for Mininet. Means the basic understanding what user has to deliver is that जब भी हमें किसी चीज को आसान बनाना है, when we are trying to make something easier, just make it a GUI version, because CLI is always horrible for most of the users. They see the black screen, the command based working, and etc. etc. They used to get panic that it is really going to be very complex. We need to remember the commands, etc. Means the main shift that we got from DOS to GUI. Similar way, if we have some GUI functionality in SDN also, it is going to be easier because you don't need to manually connect the nodes with each other. You don't need to manually configure the IP addresses and the default subnets, etc. So just you need to take the nodes from here, click here, those will get dropped here. Then you need to choose the links, connect those, choose a controller, put it here, set those up and do it. So like this, it is going to function. So Mininet in action, how it is going to look? It is going to look like this. There are going to be, there might be number of nodes here. There are going to be some sort of OpenFlow switches or the forwarding devices here, and one OpenFlow controller. So here the controller is indirectly controlling. That's why this dotted line. The controller is indirectly controlling the switches, and those switches are controlling the, means not controlling, sorry. Those switches are linked with the respective hosts or the end user terminals. Then you need to control, you need to connect in these two switches also if you want to communicate from here to here. Okay. So in this way, Mininet is going to function. So this is the window. Here it is switch. Now, before this, you just scroll over the icon and you will see the meaning. Here it is the select. Whatever you want to select, just click on it and then you select any individual component. Here it is the host terminal. It is the switch. O is written, it is in the form of O, means it is in the OpenFlow switch. It is the legacy switch, means the traditional switches. It is the legacy router, and it is the network link, and it is the control. So as we are trying to design obviously the SDN environment, so we just simply take two switches, two terminals, and one controller. Very simple configuration we are going to show you here. Hosts are connected to each other, and then switches are also connected with each other. Then controller is controlling switches, and switches are providing the functionality to communicate traffic from H1 to H2. Then after this step, you need to go into the preferences under the edit option. Under the edit option, go to preferences, and here start CLI. The command line functions would
Sir,
not
how
work.
to get the dotted line there?
It will come automatically. It will come automatically. You just need to choose this. 1 minute. See here. I'm right clicking. Not working. No, it is already stopped only. We didn't run it. Yeah. Actually, right click is not working. I am deleting through keyboard. So just click on the specific link and then delete it. See here, the network link, simply choose it, click on it, then click on controller, then drag the cursor and drop at switch 1. It will come automatically.
Okay,
Do it
sir.
again. From controller to switch 2, it will come automatically. The same link will work differently when you connect the switches. See, means it is inherently programmed that if you are trying to connect a switch with controller, then the line will be displayed in dotted form. If you are trying to connect it to switches, then it will be a solid line. Similarly, the logic stands for H1 to S1 communication, means the host to switch communication. It is just for representing the fact that controller is indirectly controlling the behavior of these switches, but the switch is directly connected with these host or terminals. So the real environment. Now again, come to the actual definition of SDN. In the first slide, I showed you here in this particular architecture, you can see it is the infrastructure layer. So it is the data plane where all the devices are there and they are going to communicate with each other. And it is the control layer. So when you come to the virtual environment, this portion, it is not getting highlighted here. So this portion is your data plane, whichever is connected with solid lines. And whatever portion is connected with dotted lines, then above then this part is the control part. So controller is going to form the control layer, and remaining all the components connected with each other are going to form the data plane. Control plane, data plane. That's it. Okay. And we are assuming that user or the applications, and the application plane was also there. So application plane, user plane, etc. All those planes are part of control plane only. Okay. So from here, you can right click and go into the properties and set various options. Similarly, you can right click and then click on the properties and set various properties. Similarly for switches and similarly for host. The different types of controllers, the protocols, the different transport layer protocol, IP addresses, etc. Okay. And then you just need to simply run it. Before running it, go to the edit option, enable the command line interface. Don't forget to do this. Enable the command line interface, make it okay. And then go to the controller. Whatever settings are here, choose it and just simply run it. When you run it, you can see here, Mininet came automatically. Earlier it was not there. We opened the MiniEdit.py. You can see here. After that, we drew a topology in the MiniEdit version and we run from there. And we got the Mininet terminal here. And directly what I'm trying to say, that we created the topology in Mininet. Here, sorry, MiniEdit. We created the topology in MiniEdit, the GUI interface of Mininet, and then we run it. Once it is run successfully, then it will show the Mininet terminal in the actual Ubuntu terminal. So you will get the Mininet prompt in your Ubuntu terminal. It signifies that whatever topology you created here inside MiniEdit, that is successful. If there going to be some sort of error, communication problem, then this particular prompt you will not get. So once you got this
And
particular,
after we check the command line option, then how do we run it?
here it is the run button at the bottom left. You can find it. Run and stop. Two buttons are here. Are you able to get it?
Yes, sir, now it is running.
At the bottom left part of the
Sir,
menu.
but it is showing that starting one controller but cannot find the required executable controller.
Okay, then go to your controller. If it is the problem, then go to your controller, right click on it. For example, I am stopping it here. See here. Go to the properties. Make the controller as remote controller. Perhaps your controller is someone else. Don't choose the any other type, choose the remote controller. Now, what is the difference among these controls? I'll tell you in the later classes, or you'll get in the theory classes. I cannot discuss everything in detail here due to time limitation. Remote controller means your controller is not going to be the part of your Mininet environment. It is a separate application. Your Mininet is a separate application. But suppose your controller is integrated with the Mininet source code only, then it is going to be a OpenFlow reference controller. Then you will choose the reference controller and it will work fine. So right now, as the VM is there, so in this VM, perhaps they have used a separate controller because we already tested it. So that's why we are choosing remote controller. Okay. And the default setup of Mininet also comes up with a separate controller in the form of POX. Now you'll question that what is POX? POX is a type of controller. Similarly, we have ODL, Open Daylight, and Floodlight, ONOS, DU. So these are different types of controllers. Any one of these you can use in your environment. But right now, just to simply choose the remote controller, make it okay, and again try to simply run it. And hopefully you will get the window. Now see here, I got the error. Earlier I got the Mininet terminal. This time I got the error. So again, I need to clean up. I told you in the theory part that cleanup is a very important one because some setup in the system files, the earlier settings are saved. So you need to clear each and every setting that is set up earlier. With Mininet, because sorry, not Mininet, with MiniEdit, you need to be extra careful because every time you'll set up something, it's a separate setting files will get stored in the system. So you need to clean up the existing setting files and then you need to set up the fresh environment. So that's why whenever there is some error, you need to clean up first, then again you need to rerun it. So if I close this terminal, I go to Mininet. I first save it because I don't want to create it again and again. So I name it 14. I save it. Then I close it. Then I open the terminal. Again, we can see that Mininet is here in the home window. Yes, it is here. So in the first we get the sudo permission. So sudo su, then cd Mininet. Inside Mininet, we are going to again go inside Mininet. Then cd examples, as we already gone into. Then we are going to list the different examples. And here it is the MiniEdit. So we are going to run this MiniEdit command. So simply /miniedit.py and we got it up. So we already saved our configuration 1.4. We'll open it up. We'll check. Controller is remote controller. Okay. We'll check the preferences. Command line is on. Okay. And then we just need to simply run it. So we run it and then we see it. Now we got the Mininet terminal. Hope it is clear to all of you. There are small issues at your side also. You are going to function slowly because obviously it is the fresh environment for you people. So it is not going to be so easy because commands are different. You need to learn the terminology. Then again, the VM speed on different systems
am working in the lab, so it might be fast due to internet connectivity. At your side, it might be slow. So don't worry. Whatever is the problem, you can text us, take the snapshot, send us. We'll try to remove it, or we'll try to discuss with you people, sort it out, whatever is best possible for you and us, and we'll see lab by lab that what is best possible for all of us. Because in 1 hour lab session, it is not possible to discuss extensively each of these things. We are working for a long period over these things, so we are habitual. We are good in with these commands. Shiv has also worked and he has also explored the P4 environment. He will teach you in the coming lab session. So it is going to be seem to be easy for us, but it might be difficult for you people who are dealing for the first time. So that's why I'm saying many of you might be of at that level that somebody has not functioned inside a virtual environment. Somebody never listened about any MiniEdit. Leave it MiniEdit. They might have not worked with VirtualBox or VMware. It might be the case. I was the same earlier. So it happens. Don't worry. Whatever is your problem, be patient, be calm. Slowly, you'll get everything. One final thing that I want to show you. Go to your Explorer and here type just simply Mininet. Type the Mininet and you will get the mininet.org. It is the ultimate source of all the information, all the commands, all the setup options, all the configuration files, whatever you need related to Mininet development. So go to mininet.org. Net speed is a bit slow right now, so it is taking some time. Once the site opens, you can see clearly then all the setup options that I explored you, whatever slides I made up there, those are from here only. Okay, so all the information you'll get here, this figure, etc., these definitions. So on the right side, you can see Mininet points to the basic Mininet information. Then you can get started. When you click on the get started, inside this, they will show you the available options to install Mininet in your system. So these are the 4 options that I discussed in the PPT. These options are also listed here in detail. So any one of you who has not followed or couldn't follow the procedure that I detailed in this particular class, simply go to this particular site, that is mininet.org. On the right hand side, you'll get hell lot of options. So many options are here. Go through each one of these one by one. Don't go randomly. If you directly try to jump on the download, okay, download is very basic thing. If you directly want to go into the source code and then you try to find out something, it is going to be hectic. First, understand the basic things. So install Mininet, have a test of the basic command. After testing the basic commands, then you go through the basic workflow that is inside the walkthrough. When you go into the walkthrough, sample workflow is a basic understanding how Mininet is going to function. The main thing is workthrough. I request all of you, if all of you are not available, means if your time doesn't permit to explore all the options, at least go through this walkthrough. Walkthrough is the main page where all the options are listed related to the everyday use of Mininet, some advanced and as well as some intermediate options. There you go, there you'll get different options like the help, the Wireshark initiation, the OpenFlow related packet separation, the sudo mn, the basic command. Again, you got the Mininet prompt, then help nodes net dumping of flows, then IP configuration that I talked to with respect to host, with respect to switch, then the processes with respect to switch, with respect to host, pinging with respect to the packet count, ping all means all the hosts will try to ping each other, h1 kill Python, killing a specific process in your system. You want to exit from your system, then test all the ping pairs, means all the network pairs, all the device pairs will test each other's connectivity. Then the performance, you can test the performance, what is the bandwidth that is available between two nodes, if its condition is good or bad, what is the connectivity, what is the packet drop ratio, everything you'll get. Similarly, you can change the topology size and type.
So here it is the single topology. Here it is the linear topology with 4 nodes. Here it is the count packets of 10 with respect to H1 to H2. Means H1 is trying to ping H2 with 10 ping messages. So similarly, sort of different options are available here. Okay, in a single class it is not possible. Slowly we'll explore these things, and at the last you'll get to have a basic idea. You'll get the basic understanding. Then you will explore yourself. And I think this is enough for today's lab. It is 4-5. Now, if you people have any question, please either put in the chat window, or you can directly unmute yourself and ask. Me and Shiv both are here. If you have any sort of question, query, doubt for us, then please let us know. Anyone? It's okay if you don't have any doubt. It might be possible that you got all the things. और ये भी हो सकता है कि किसी को कुछ समझ में नहीं आया. So it's okay both ways, no problem. Slowly everything will be fine. So I think if you have any doubt, you can mail us also. Okay. So we are going to close this session for today. In the next lab, we'll discuss some more issues about Mininet, and we'll get a more hands-on practical. Because in this particular first lab, we discussed some theory sessions, means some theoretical contents also. That was necessary. But in the next practical lab, we'll directly go on to the hands-on, and we'll explore more practical aspects of Mininet. Okay. So thanks for the session. Goodbye. Shiv, वो स्क्रीनशॉट ले लेना है.